Acquired by Bentley Systems, and I'm the Senior Director for Open Standards. We believe so strongly in open standards at Bentley Systems, and that we are so engaged in Kronos and AOUSD and OGC and other standards forums, and we're excited that you're here and hope that you get engaged with these standard forums as well. One of the things we love about the standards world is that we work on this stuff together as a community, and we just crave your feedback. We crave your use cases. We crave your input from extensions and GitHubs and all the things we're working on. One of the things we do at Metaverse Standards Forum is work on interoperability between standards organizations. So today you're going to hear about some of the things we've done in the past, some of the things we're working on today, and leaning forward a little bit what we're looking forward to in the future. So I'm excited about the talks that we have coming up today, and I'm excited that you're here. Photography is welcome in this session. Please take pictures if you want. There's going to be slides and video recordings online at the MSF website. And there's more information if you want to get involved in the Metaverse Standards Forum. Please, like I said, join us. That's how we thrive. These are the speakers I started talking about today. We're going to talk about the Kronos side and the glTF aspect. Neil Trevett will be talking about that for us, what MSF is, what we do. Guy Martin's going to talk to us about OpenUSD and AOUSD. And of course, all these people that you're going to hear from, they also sit on each of these boards from Kronos and from MSF, but they also sit in these working groups where we work together and move this work forward. We have Marc Petit talking about FBX, interoperability. Nick Porcino isn't here yet, but he will be joining us. He's reliable enough to be here. He's coming straight from something else, so we know he'll get here. If we have to pass him over and come back, Henrik is here. So we're going to talk about PBR interoperability, material interoperability, and then again, like leading forward, we've got Adam Morris here to talk about 3D Gaussian Splatting interoperability between USD and glTF. And then we're just going to open it up and do some question and answer sessions. So I hope that you'll write down your questions, think about what you want to ask, because you've got an array of people in this room that want to talk about these 3D assets and how we're keeping these standards interoperable. So with that, I'm going to turn it over to Neil Trevett to talk about MSF and glTF.
Thank you, Amanda, and thank you for stepping up all the good stuff you're doing with all these groups. So I think I have 5 minutes to introduce Metaverse Standards Forum, the Kronos Group, and glTF, and everything that the working group is doing. So I'm going to start, and I'm going to speak quite quick. So we are being hosted by the Metaverse Standards Forum. So the first question everyone always has, well, what's the Metaverse? This is our current best definition of what the Metaverse is. You start with XR, which is the XR head-mounted devices of various shapes and sizes, AR and VR. But increasingly they're using AI to understand their environments. So we were doing spatial computing, where those devices are interacting with their users, they're interacting and understanding their immediate environment. And then you have multiple folks who are doing spatial computing, and you connect them together in a very cool way with composing multiple spatial experiences. And yeah, we can turn down the echo. I feel like a rock star.
Sorry about that.
Yeah, no problem. Often services being triggered by proximity. Then you have the Metaverse. So the Metaverse is going to be a platform. It's the evolution of the web. It's going to provide multi-user, multi-agent interactions, persistent placement of 3D in virtual and real spaces. You're going to have avatars, and it's all going to be delivered in a Metaverse browser. So it truly is the 3D evolution of the web. And of course, the rocket fuel that's both enabling and promoting all of this is AI. You have XR and spatial computing, and then you add in AI that is solving all these hard problems of understanding environments and users. AI is going to need the Metaverse. The Metaverse is going to be one of the primary user interfaces for AI. And the Metaverse, in many cases, as it becomes physical with robotics and autonomous agents, it's going to be using the Metaverse to get trained on how to interact physically with the real world. There's so much awesome work going on here, all through SIGGRAPH and all these aspects. The Metaverse Standards Forum is a place where we recognize where all of this to come together is going to need a constellation of standards from dozens, if not hundreds, of different standards organizations. We have 2, 3 primarily represented here, which we'll talk about. But there are many others. There's no single place in the industry for all those organizations to go around one table and interact with the industry, and that's what the forum is about. We're not a standards organization ourselves. We're not competing with all the dozens and hundreds of standards organizations that are out there. We're trying to help to accelerate their mission, pre-standardization activities, gathering use cases, requirements, and what the industry needs, feeding it into the standards organizations. It's always surprisingly difficult for standards organizations to gather that data from the industry. We have 2,600 companies that have joined the forum to help us do this. It gives good visibility to what the standards organizations are trying to do, good input. And then we do post-standardization activities. Is the shipping standards from the SDOs, are they working? Can we do test beds? Can we do plug fests? Feedback, real-world data back into SDOs again to help them with their mission. The way we organize inside the forum is we have a number of domain groups. So we pick areas where there are interoperability issues, interoperability pain points, and see what we can do to help, bringing together SDOs and providing them the data incorporation. Broadly speaking, there's APIs that make things work together. From the Kronos point of view, OpenXR is a good example. Data. So you can have systems understanding each other. So OpenUSD, glTF are 2 good examples of 3D asset formats. So you have understandability between different platforms. The human interaction, again with AI, is becoming increasingly important. And last but not least, the societal needs to have regulations, even laws around ethics, privacy, cybersecurity, decentralized services, economies online, many different aspects to have the right standards to make this new generation connected platform come into existence. One of the working groups is why we're here today. It's the glTF USD interoperability working group. The realization that glTF and OpenUSD are both awesome, and the industry needs them both. And we're going to best serve the industry if we can coordinate and cooperate on how these 2 standards evolve. We want to avoid needless friction points between the 2 standards as they focus, as they should, on their own missions. So glTF is focused on it being a delivery format. OpenUSD is a whole powerful framework and an asset format to do composing, simulating, and collaboratively working in 3D spaces. And we have ASWF as well. So Henrik's going to be talking about OpenPBR and MaterialX becoming increasingly important both to glTF and OpenUSD. So again, multiple SDOs coming together is the theme here. So if you're interested, as Amanda was saying, please get involved. You can get involved in the forum for free. There's no cost. We asked some of our members to up level so we can actually keep the lights on. We're a non-profit, but essentially it's free and open to anyone who wants to join. The working group has run a really fantastic series of education sessions where we invite industry experts on a variety of relevant topics to the glTF and USD communities, and we post it on YouTube. Everything the forum does is publicly available, so check it out. Actually, it's quite interesting. I'm actually now spending my evenings not watching soaps, but watching glTF USD YouTube channel. I know, that's dedication. And we're going to talk about, in just a moment, a couple of projects that we're doing. We're looking to have glTF USD round tripping. We call it round tripping, but good interoperability to do, so you can hop between the 2 over time, hopefully easier and easier. And also we've had a request from the industry to try and, with Autodesk's initiation and support, try to absorb the capabilities of FBX into OpenUSD and glTF, which is still a thing, and a lot of folks would like that to happen. It would smooth out some friction points in a lot of people's tool chains, but Marc is going to be talking about that. So the last thing I'm going to talk about, and then I'll hand over to the OpenUSD folks, is what is Kronos doing. So Kronos, if you haven't come across this before, we're a non-profit, we are a standards organization. We focus on low-level APIs for things like 3D graphics and AI acceleration, XR acceleration. And we have about 150 members, we're global, open to any organization. You do have to pay to join Kronos, but it's not a lot, and it's a good deal. So again, if you want to get involved in the hands-on development of standards, please do consider joining Kronos. This is actually a special year for us. This is our 25th SIGGRAPH since we were formed. You can see some of the standards that we've created. glTF there in the middle, of course. glTF is focused on being a transmission and delivery format. It's a focused goal. We so far have kept our discipline and kept to that focused goal, which has resulted in glTF being quite simple to use and deploy, which means it's deployed pretty much everywhere. Our mission is pervasive 3D, being the JPEG of 3D, so there are tools, there are engines, web engines that are using glTF pretty well everywhere. One of the nice things about glTF is it's an ISO standard. Kronos is a ISO pass submitter, so we can keep the ISO standard of glTF to date. And we're working with a number of verticals, some of which we're going to be talking about here today. And the verticals often are represented by other standards organizations. So Open Geospatial Consortium that Amanda mentioned has 3D tiles, which is a set of glTF extensions. VRM, some of you might know, is an avatar format, very widely adopted, primarily in Japan, but going global. That's a set of glTF extensions. The MPEG folks doing video now with immersive 3D inserted into video is using glTF. Even the PDF standard, which is another ISO standard now, has glTF inside it. We have a very active roadmap. Am I doing on time? I'm a little bit over. Okay, this is my last slide. We have an active roadmap. I won't go into the details. There's a lot of stuff going on in glTF. Everything we do is open and on public GitHub, so come and give us feedback. But this makes it super important that we talk to OpenUSD and the AOUSD folks, because we want to be aligned with what we do, with what they do, so in the future that we don't have needless friction points. So glTF loves OpenUSD. We love this opportunity to talk together and to align and be cooperative. So, Guy, over to you.
Okay, hopefully. Thank you, Nick. So, let's see here. Yes, hi everybody, I'm Guy Martin. In my day job, I help run open source and standards at NVIDIA, and I'm really lucky and privileged that I get to sit on both the Academy Software Foundation Board and Alliance for OpenUSD on behalf of NVIDIA. So, we have a birthday, not quite 25 years, but 2 years as of SIGGRAPH this year, where we launched Alliance for OpenUSD, really as to something Neil said, to actually create an ISO standard out of USD. And Pixar obviously was a huge part of that. They're making that technology available as open source. They've done a lot of great work with us in the Alliance to begin to get to where we need to be in terms of making it standard. So we just celebrated 8 new general members that joined as of this SIGGRAPH. We have 46 total members from 7 total members when we launched. So obviously there's a lot of momentum. There's a lot of companies. I mean, you can see the example companies here, but what I love about this is, we started with obviously more of a media and entertainment focus because that's where the origins of USD were, but there's a great recognition by everybody from industrial manufacturing companies like Siemens to retail companies like IKEA and Lowe's, and really everybody wants this to be essentially the HTML of 3D. Oh, sorry. Oh, Neil, somebody's laptop is super touchy. There we go. Okay. So we have two governance constructs in Alliance for OpenUSD. We started with the concept of a working group whose job is to produce those normative specifications. And then about a year into our existence, we realized we had a need to have additional stakeholders that weren't going to be part of building standards, but were going to do a lot of the pre-standardization activities that Neil mentioned. So we created the concept of interest groups, which are free to join. To join a working group, you have to be a general member, which has a fee. But in terms of working groups, we have 4 total now. We have 1 new that just started. The most important piece of this is a core specification, which is kind of the foundation that we're going to build everything else on, is on track to get their version 1.0 out by the end of 2025. And having run a couple of standards organizations and bodies in my time, I can tell you 2 years to get to what could be potentially an ISO standard is lightning quick, so they've done a great job. Our new physics working group is basing their work on some existing work that NVIDIA and Apple and Pixar did together for the rigid body schema, and that will follow very closely on probably sometime in early 2026. And as you can see, our geometry working group's doing a ton of great work. The one I want to highlight is the BREP schema. They have that out for internal review, so a lot of the work of Siemens and others to be able to reference CAD data and bring it into OpenUSD is super important. And then finally, the materials working group is working on the very hard problem that we all know of physically accurate materials, and they're working very closely with the MaterialX project at Academy Software Foundation to figure out how we build those as nodes for USD. In terms of our interest groups, we have 6 of these now, 3 that are new. One of the things that was just announced here at SIGGRAPH was that our DE&I, Diversity, Equity, and Inclusion Interest Group is working really closely with the Academy Software Foundation to do not just things that are inclusive to different groups, but also things like accessibility, documentation, and things in the API. Our architecture, engineering, and construction group did a prim name grammar that they are sending to our technical advisory committee. So again, work that's going to be absorbed into future standards, such as what's going into core spec. The newest working groups we have are the Build Interest Group, the Industrial and Digital Twins, and the Web Interest Group, which is actually a critical one. It works very closely with the Academy Software Foundation community to figure out how we do a good job. And this is obviously where it interacts with GLTF, and we kind of have to figure out what those friction points are and remove them. Emerging geometry, I know Adam, you're going to talk about Gaussian splats, so there's some Gaussian splats work going on there. So I think that there's a lot of surface area for us to collaborate on. In terms of liaison, so one of the things that we did when we started AOUSD is we realized we didn't want to do this all on our own. We couldn't do this all on our own, so we needed to have liaisons. Our 2 existing liaisons when we launched were with Kronos and with Academy Software Foundation. And we're really happy that in the last year since we talked to SIGGRAPH last year, we've added Alliance for Open Media, which is working on streaming media compression and how that interacts with USD. We are working with the Association for Manufacturing Technology, which has a standard called MT Connect, which lets you control CNC machines and other industrial machines. And then we're also working with Building Smart, who are the authors of the IFC standard used in architecture, engineering, and construction. So a lot of great work going on in terms of the liaisons. And I think I'm good on time, so I'll leave you with this. So Metaverse Standards Forum really is kind of meeting all these communities where they live, especially the work that we're doing, that Patrick's doing with us in the 3D interoperability with GLTF and USD. It's touching all of these. It's touching Kronos and GLTF and what's going on in the Academy Software Foundation, and then obviously what we're doing in OpenUSD. So we're really excited that Metaverse Standards Forum is the place where a lot of these things come together, because each of these organizations, as Neil said, has to work on their own mission and do certain things to make that work, but they also have to have a place to come together to make it easy to actually have these cross SDO discussions. And with that, Marc, I'll pass it to you.
Thank you, Matt. Marc Petit to the floor to talk about FBX interoperability. Thanks, Marc.
Thank you. So we're going to talk about FBX. So my name is Marc. I think to understand what we're trying to do with FBX, we have to go back a little bit in history. So 30 years ago, FBX was a native persistence format of an application called Finbox that became known as Motion Builder and became mobile, still around. It was a real-time application, and the necessity that the company funded Kedara had to interface to Maya and to Softimage because we get smart. So they were led to write this publishing format that was optimized to transport animation data and skeletons and characters. So that was the genesis, I would say, the first 10 years. 20 years ago, we at Autodesk purchased Alias, and so we got all those teams under the same house. So suddenly, we kind of, we made the decision that interoperability mattered. We could call it interoperability at the time, and so the agenda of FBX became to become, that to drive interoperability between all of the software tools of Autodesk, so 3ds Max, Maya, even later Softimage and Motion Builder. And in the history of FBX, that drove a lot of new capabilities, like you'll find the format like NURBS, but there was a lot of Maya in the automotive industry and particles, and so it became a very, very big endeavor to try to manage cross DCC interoperability. So we went from being a publishing format to become, more of a data interchange format. And the other thing that was important is, since day one, when we were transferring animation data, that data was relatively ambiguous, and then we had this always problem of, coordinate systems. You famously know Max and Maya do not share nothing in terms of coordinate systems. And when it comes to rotation and geometry, it can be very tricky. So very, very early we were led to develop the FBX SDK, which I think in what we was reading was as important and as valuable as the format itself. So there's a lot of people that actually use other formats. I use the FBX SDK because it does solve a lot of, it's not complex, it's geometrical algebraic problems, but you have one function calls, to take an object from one coordinate system to another. You don't need to understand quaternions, you don't need to understand rotational geometries. You don't need to understand any of those things. So a lot of the value when you look at the usage of FBX was driven by that FBX SDK. So not only you have the format, but you have that SDK. So today, 10 years ago I left Autodesk, the interactivity agenda was basically set. There was a little bit less of an interest in FBX. And in the meantime, the industry had launched on open source initiatives. So the return on investment for Autodesk, I assume it was not there anymore, was less. And so kind of the SDK, the FBX started to plateau when it was Alembic and glTF. So it was even Colada in the early days to try to take over. Oh, yeah, there you are. Try to take over the interoperability agenda. So now we're, 10 years later, we are with the legacy of FBX, the legacy of the FBX SDK. Autodesk is, it's a meaning weakness now. Autodesk is, and we all realize that the open source platforms are mature. They could very well, take the entirety of that interoperability agenda on their shoulders. And so that's what we've been trying to do now is, again, with the support of Autodesk and everybody, is try to orchestrate the migration away from that legacy of FBX to the new formats, and do it in a way that would work both with USD and or glTF or any other standards. So that's what we're trying to do. It's a very ambitious program. As I said, it's not just a format issue. We've got the FBX SDK, that we kind of have to invent a future too. So there is open source code to be written, IP issue to be managed, and we have format specification work to be done. Particularly around motion data and all that. So it's taking time. That's what we're doing. We're doing the workflow analysis. As I said, FBX has a legacy of a lot of issues. We don't care about NURBS. We're not going to use the FBX for particle systems. We just want to be laser focused on the stuff that matters to reduce the scope of the effort. And the stuff that matters is the motion data, the character data, even though the FBX skeleton is kind of the de facto standard anyway, so there's probably more work to be done there. The structure is already largely used in glTF in other format. And then FBX still play an essential part in the communication between DCC and game engines. So that's one of the use cases that we want to make sure that we can cater to, that we can export. It's, we see more USD, we see more glTF, but there are still many people relying on on FBX. And again, I don't think the reason is because the format is so powerful. It's because the FBX SDK in those translators plays a big role. So that's where we are in the thinking. You know, we are very much aware of that SDK issue, and we are very focused on the certain use cases that actually will matter. So the work that has started was a very simple logical step, which is to do a gap analysis, look, what's USD do, what the glTF does, and identify the gaps. So we've done some of this work, and then we'll act upon it. We're acting upon that to actually bridge those gaps. Stuff that's a one-liner on a spreadsheet to gap analysis can be a lot of work. And Nick will talk about this. When you think about, for example, vertex level data, that's a one-liner on the spreadsheet, the gap analysis, and that's the whole amount of work. So that's happening, and again, our approach is to try to be holistic, and remember that it's not just a translation of format issue. It's a workflow issue, and try to build a complete solution that people can migrate easily away, and with progress in their pipeline. Because if it's, people will not challenge their pipeline if they don't see value in it. So we need to address the issue holistically. That's why in our implementation plan, of course, we want to create detailed specific implementation guideline that we would submit respectfully to the people who understand their please do that. That would be cool. And then also a lot of supporting resources around open source code as an alternative to the MaterialX SDK, sample scripts plugin, and all of that, all of that good stuff. So a lot of work. It's a lot of resources as well. So it's a presentation and a call for help and support because it's we're lucky we're a few issues that are to be tackled, but the spreadsheet is pretty long, and so that's a pretty long endeavor. But I think at the end of the day, I think we're all going to be better off if we manage to sunset and deprecate FBX for some of the critical workflows that we discussed. And again, we're super happy with the support of Autodesk in that endeavor. I think it's going to be a good thing for all of us. So that's where we are. So if you have ideas or time, if you love algebraic programming and all that good stuff. Now with AI, you could value code that stuff, right? I thought about that. So this is it. Thank you so much.
Thank you, Marc. I love that you talk so much about use cases and scope, because one of the things that we really are focused on is as we're looking at this interoperability and as we move back and forth, what are those pain points? What are those issues that we find in our normal everyday use cases? And that is really where we're scoping our work and where we're trying to focus our efforts right now. So you'll hear that again from Nick and from Adam and as we go forward. So thanks for talking about that, Marc. This is Nick Porcino. He's going to talk more about the tooling pain points, speak of the devil, and let us know where we are, and we would love to hear from you too. So thanks, Nick. Well, please welcome.
Hello, everyone. So I've got the document here that's resulted out of our effort on that one line on vertex attributes. Do you care to guess how long the document is in terms of pages? Oh, come on, anyone?
25.
Anyone else? It's 51 pages so far. Factor of 3 explosion of bloat. So that's a result. It's kind of jumping ahead a little bit. It's called Pain Point Project, which I thought was kind of funny, and I left it there sort of ironically because the pain point that you're talking about is it's basically the hysteresis that occurs between the fact that you've got a difference between the representation of data, of the datum in a file, and the semantics of the datum. So everything carries all the information that you want in some regard. The points, the normals, UV sets, and things like that. That's all fine and dandy. But when it comes right down to it, it's one thing just to have like, a bucket of bits, and it's another thing for that bucket of bits to mean something, and that's where the pain in the project comes from. And if you look at something like OpenUSD, where are the UV sets? Maybe they're in printbars : UV, maybe they're in printbars : ST, maybe they're in UV, maybe they're in ST, maybe they're in UV map, who knows? Anything goes. If you have a look at glTF, and my first cut at the document before Felix, I don't think Felix is here today, but my partner in crime, Felix Herbst, did a great deal of work on this project. And he corrected what I had written down, which is that ST corresponds to text coordinate 1. No, Nick, and you have to have text coordinate 0. You cannot have text coordinate 1 without text coordinate 0. Like, oh, okay, well, anyway, we can have UV2 maps to ST coordinate 2. Yes, Nick, but only if text coordinate 1 exists. Like, what? That's really complicated. Are you sure? So that's a difference between like semantics. You've got the bucket of bits, but does it mean anything without a lot of interpretation? Not really, and that's why it's an interesting project. All right, what do we have pending for me on the slide here? I need glasses. Yeah, so what we basically did was we looked at Marc's spreadsheet and we went through it and we tried to find what's the most impactful thing we can do in order to try to start to move from the things that we hear in the field, like we really want to use USD, we really want to use glTF, but at the end of the day, we're all this falling back to FBX and honest to God, OBJ, and it's like, why is that? And so the why is that is because there's interesting semantic data that's carried in all these formats that's really difficult to move away from, move around, or implement in a different way just due to like the endemic existence of facilities like a standard format for skeletons. And so we went through the spreadsheet and we thought, what's the highest impact thing that we can possibly find that seems self-contained and cannot possibly be confusing? And that's got to be vertex attributes, yeah? So we took vertex attributes first, and I bet it's going to be the biggest one of them all. Because it's the easiest one and the most obvious, because of course it's the easiest and most obvious. And so we worked on it. We got a bunch of people together, lots of community contributions. We made a Google Doc, got it refined and refined. Yeah, you don't have to try to pretend you can see my tiny screen over there. And it's nearly ready for presentation. So we've been running in our bi-weekly meetings a little time block session, which has been super productive. So if you can show up for the Interop working group meetings with, a helping out hat on hand, we try to spend 15 minutes at the end before the water cooler to just try to knock off some concrete topics. Can we just push the Sisyphean ball a little bit higher up the hill? And that's been like really fantastic. And this giant document wouldn't have got done without just repeatedly coming back to knock your forehead against the wall productively. So I think I haven't been watching my time.
You have about 5 minutes.
5 minutes. So I think that's sort of my call to action here is the first thing that what we looked at was vertex, and I think we're drawing rapidly to a conclusion. We need to pick off another line item on the spreadsheet and pick what's next. And like just listening to Marc talk, it really sounds to me like motion data, and is probably the smart next thing. Or maybe skeletons. Maybe we shouldn't talk about motion data without skeletons. Do you have an opinion?
As I said, I think skeletons is kind of a non-issue because everybody.
Because we could just use it, and we just have to sit down and do the semantic gap analysis and say this is how you map it from one to the other. So there it is. That's what we're going to work on next. We're going to work on motion data next. After working on skeletons, only briefly because it's going to be super obvious, and it's not at all going to turn into 51. It's not at all going to turn into 51 pages. Not at all. And I'm hoping also to that we can rope in folks from VRM and other adjacent communities to talk about things that FBX doesn't cover. like the yarn folks, they've got ponytails and wings and all kinds of other interesting things that they bring along in a standard way, and we should be able to talk about that in terms of an interoperability forum. And I do actually just want to give you sort of an idea about like why this thing is so huge. And the reason is because there's a first thing you have to do is you have to do an analysis of what's going on between them, like find the technical gaps, like the ones that I mentioned at the beginning, the lack of coherent semantics across formats and things like that. And you need to figure out like what are the data's, the representations. Is it a V3D? Is it a V3F? And you need to identify like what are the lossy points. And if we go to GLTF, and there's only floating point attributes on certain aspects, and that means right away you're throwing away information that might be critical in a field like CAD/CAM. So you need to like write that all down and put it in like in a risk category and talk about quality metric assessments. You need to say what you do for missing attributes and lay out what are all the implicit behaviors, what are the mitigations of the implicit behaviors. And at the end of the day, once you work through all of that, then you have to like lay out a whole bunch of like processes to follow, like do these things in these orders. Here's some reference assets, try converting them through the pipeline and see what drops on the floor. There's a lot to it, and it's super interesting. And I hope that lots of people can join. We've got a few hardcores who show up for everything, and we need more because, gosh, there's a lot of work and this takes a lot of time. So, thanks very much.
Yeah. Thanks, Nick.
So let me just say, it's such an honor and a pleasure having Nick working on this. As many probably know, Nick is the OG for so much technology that we all use every day. So thank you, Nick, for spending your time with us. We did have a slide here. So this is a link to the Discord thread on the forum Discord channel for the working group. That's where we're gathering input. So if you have pain points that you would like us to put on the list for the next 50-page document, please go there and let us know. We'll be monitoring that. So yeah, thank you.
Thanks, Dan.
And Nick, I need to introduce you to Ken, who's working on avatars. So yes, we'll introduce you a little bit.
Thanks, Neil. So speaking of hardcore MSF interoperability members, we have Henrik here, who is going to. Did everybody get that? We'll come back to this at the end. So if something else comes up for you, here we go. So Henrik's going to take us through PBR material interoperability.
Yeah, so when it comes to 3D asset interoperability, materials is obviously one of the first things that come to mind, that we need to preserve that the appearance of the asset as it goes between different formats like USD and glTF. So I think before we go into the specific formats, it is useful to keep in mind that some of these formats, they originate from like different different workflows or different perspectives, like Neil talked about earlier. glTF is very much a last mile format, a delivery format where you kind of optimize for transmission size and portability and so on. Whereas some of these other formats are more focused on workflows where you're collaborating across teams and using different editing tools, possibly from different vendors, and you need to preserve the full, preserve everything, all the data in the model. So when it comes to the materials, these different standards have taken different paths to kind of get to where they are today and made different trade-offs. So there is a reason why we have multiple different, shading models and why these formats are, looking at the material problem in slightly different ways. So if we start with MaterialX, this is just going to be a very, high-level intro for those who are not familiar with it yet. This project was launched by ILM in 2012. And it's designed to express materials independently of where they are authored and where they are rendered. So you can exchange materials between different editing and authoring tools, as well as renderers. Those could be both real-time renderers and offline renderers. That's a misconception that we sometimes hear, that MaterialX is purely offline focused, which is not the case. It was designed from the very beginning to be real-time friendly as well. So the project was open sourced in 2016, and it joined the Academy Software Foundation in 2021. And we have a large range of companies that are very actively contributing to MaterialX, and we from Autodesk have been heavily involved since 2015, even before it was open sourced. So there's also some confusion, like how does MaterialX compare to OpenPBR and glTF PBR, like how do they relate to each other? So MaterialX is this kind of comprehensive framework to express everything you need around materials. So originally, it was very heavily focused on expressing the pattern graph, so basically the texturing. So that could be bitmaps, of course, but also general procedural node networks to drive the inputs to your shading model, like the color and roughness and index of refraction and those parameters. MaterialX later added also PBR shading graphs, so that's another node graph that can express various different physically based rendering shading models, like OpenPBR or glTF PBR, but basically any other modern PBR shading model can be expressed as a node graph inside MaterialX. So that's how MaterialX relates to these different shading models. MaterialX also comes with a few other components, like the shader gen framework that can help you integrate MaterialX into your pipeline or your engine, so you can kind of generate shader code from these two node graphs. Another part of MaterialX that is very relevant here for the interoperability aspect is something we call shader translation graphs. So this is basically another node graph that expresses the mapping from one shading model to another shading model. And this is a very flexible and kind of robust way to kind of maintain those mappings in a data-driven way, so it doesn't sit in some sort of obscure script or tool. It is a very accessible graph representation of the map that maps from one model to the other. And as all these standards continue to evolve, this is also a good kind of place to keep that mapping up to date, as both the source and destination model keeps evolving. So if you go to the MaterialX project, there are 4 node graphs there, translation graphs already, but obviously you can write additional graphs for any other models that you might need. And as you can see in this list, there are a couple of ones that could be useful that are still missing. So that was MaterialX, very high-level intro. So what is OpenPBR, or more specifically OpenPBR Surface? Because now we also have, we recently announced that there is an OpenPBR volume. So this is specifically for surface material shading. And again, this is an open specification for an artist-friendly Uber shader. It's also governed by Academy Software Foundation. And it's a result of a collaboration between Autodesk and Adobe in merging our 2 previous initiatives in the Uber shader space, so Autodesk Standard Surface and Adobe Standard Material. And with this very comprehensive shading model, you can accurately represent most of the materials that you will encounter in practice. And that goes both for film and VFX and architecture and design visualization type of materials. Here is also sometimes a misconception that this is purely offline focused. There might be a slight offline bias, I would say, just considering the heritage or where the shading model comes from. But it's certainly the idea here that this should be real-time friendly as well. And as it is an Uber shader, it's relatively within quotes easy to map back and forth between other Uber shading models like glTF PBR. It's not necessarily lossless though. So I think this one can be useful because sometimes people wonder, okay, how did we arrive at OpenPBR, and why didn't we work more closely with, let's say, the glTF PBR working group in defining the parameters and so on. But it actually has a heritage going back over 10 years, and it's kind of like an evolution of these previous shading models that have been heavily used in practice. Both for offline rendering and film and VFX, but also, like in the case of Autodesk physical material, that was, and also actually MIA material from mental images, and those were very heavily used in architectural design and product design visualization. So that's kind of how the parameterization and what the shading model looks like is kind of based on all these previous shading models. So of course there is a specification. We won't have time to go into like what the actual surface model looked like and all the different components, but you can find the specification, of course, at the website. There was also a DigiPro publication that came out last week that also goes into much more detail on how we arrived at this shading model. So that was OpenPBR. So let's go into Kronos, the GLTF PBR model in GLTF. So this one goes back to 2017. GLTF 2.0 introduced this very basic metal roughness PBR model. And here we're taking a different approach. So in the case of the shading models I showed earlier and OpenPBR specifically, we kind of started with the whole comprehensive Uber shading model from day one basically, and then everyone had to go and implement that, which can be a bit challenging. So with the GLTF we took a more incremental approach, adding kind of one aspect to the materials at a time and making sure that it was well supported by tooling, different renderers, both real-time and offline, but here we have maybe a little bit more real-time and web bias. But we do validate all the different extensions and parameters in path tracers as well. So if we go up to where we are today, the most recent additions here to the GLTF PBR model is diffuse transmission and volumetric scattering. And so we're getting very close to kind of having the same phenomena, be able to express the same phenomena in both OpenPBR and GLTF PBR. The difference is that GLTF PBR typically doesn't expose as many parameters, so you don't have that fine-grained control necessarily over every single aspect of the material, but that's a trade-off that we are willing to make it more efficient and more portable. And there's also an initiative on extending procedurals in GLTF. So originally we were only supporting bitmaps as input to the PBR shading model, but now we have two extensions. One is just general support for procedurals, and then we have one that specifically supports the MaterialX, the procedural graph, the one that I showed on the left-hand side. So you cannot, so the PBR shading model is still fixed, but the inputs to it, can be expressed as a procedural node graph. And there is also ongoing tooling here to help bringing a MaterialX procedural graph into GLTF and vice versa. All right, so kind of bring it all together. So what do we need here to make this work in practice? So if you're in USD, it's general, you have lots of options, but if you're interested in interoperability, MaterialX would definitely be the preferred way to represent your materials. Ideally, you would use OpenPBR as well, because we are intentionally trying to keep GLTF PBR and OpenPBR as compatible as possible. But you can certainly use other shading models as well, and they might map reasonably well to GLTF as well. But then we can strongly recommend using translation graphs. We've had great success at Autodesk in doing that. I know IKEA has been vocal about using that a lot in their pipeline as well, as they are using both USD and GLTF and going back and forth. So I showed you some of the list of the translation graphs that are in the MaterialX repo. So it would be great to add two new ones to go directly from OpenPBR to GLTF PBR and back. But we can support other shading models as well through the translation graphs, like standard surface or USD preview surface and other models that are still in very active use. There is a GLTF PBR node, which again was a middle graph that I showed earlier that expresses the GLTF PBR shading model inside of MaterialX. But it's not fully up to date, so there is some work remaining there to add the missing extensions. And we also need to make sure that it keeps up to date as the GLTF PBR shading model is evolving. And again, I showed you some tooling earlier, but there's probably more work we can do in that space to help simplify the translation back and forth. But I think the key here is going through MaterialX to map between the different shading models and just making sure that we keep that up to date as you know, both OpenPBR and glTF PBR keeps evolving. So that was just basically a quick recap on the last 2 years of discussions that we've had in the working group. We did have an education session from Jonathan Stone, who leads the MaterialX initiative under ASWF, and Ed Mackey, who is the lead for the PBR working group within Kronos. So if you want more details on this particular topic, please check out the recording there that's been posted on YouTube. Yeah, that was a quick intro to this topic, and please join the working group if you have opinions on how this should be done, or if you're interested in contributing or helping out. Yeah, please join us. Thank you.
That was great. All right, so now we're going to move into some other work that we're doing right now, and as we lean forward into this interoperability work, you may have joined us in the other MSF Frontiers workshop, where Patrick led us in Gaussian Splatting and Are We Ready for Standardization? And so now you get a look into how we're looking before we even standardize in glTF or in USD. What are we doing right now to talk to each other, to integrate together, and to make sure that we're interoperable as we lean forward? So, Adam? Thank you.
Afternoon, everyone. So I'm Adam Morris. I am an engineer working in the Cesium ecosystem at Bentley Systems. I am one of the co-authors of the glTF proposal that I'm going to show you today, and I want to give a shout out to Drew Goebel at Apple for the proposal from USD, because he's the main author of that, and I want to make sure he gets the full credit there. We're working closely with them to make sure that what we've got in glTF and what is going on in USD is kind of equal and interoperable, and that's what I'll be talking today about. First, for the two people probably at this point in the crowd who don't know what 3D Gaussian splatting is, it's an efficient radiance field reconstruction method. And it uses a sparse cloud of volumetric 3 Gaussians to represent splats in a scene. We use spherical harmonics for view-independent lighting that allows us to do non-Lambert-Gaussian effects and reflections and that sort of stuff. You can see the real benefit here, though, is that it does thin structures really well. It is extremely photoreal, and it's way more efficient compared to NERF when it comes to actually processing and then actually rendering these. So first up, I'm going to talk about the OpenUSD proposals. So there's two proposed schemas, the Gaussian API and the Spherical Harmonics API. Both of them are built upon USD geom points. Position and width is provided by the USD geom points, and then it exists within a new USD light field namespace. The Gaussian API schema defines two arrays, orientations and scales, both in half or flat, float or half precision. The Spherical Harmonics API defines an array for spherical harmonics in float or half precision. And it provides rendering hints for basically projection use, sorting method use. And both of these hints are non-comprehensive and they're open fields, because we want to make sure that this is as extensible as possible, and this provides a good foundation to continue to build upon as Gaussian splats evolve. And so the rendering hints actually, we stole that in glTF, and I'm going to talk about that next. So in K-chart Gaussian splatting extension, the K-chart Gaussian splatting extension is kind of a base foundational extension, and we're using point primitives. And the primitives rely on the base glTF spec attributes for position, diffuse color, and opacity. We've decided to take at least with glTF, we've decided to take the diffuse color components of the spherical harmonics and actually turn them into a GPU renderable color with the opacity encoded into the color alpha channel. That is to allow for a very graceful fallback in the case that an engine loads up this file that doesn't actually support Gaussian splat rendering. Well, then it'll just be treated as kind of a very sparse point cloud. The extension does define additional attributes for rotation, scale, and the spherical harmonic coefficients. The spherical harmonic coefficients are actually optional, so in the event that light fields change and you've got relightable Gaussians that use a different method or even use PBR, well, you'll be able to use different methods for actually doing that. You don't have to use the spherical harmonic coefficients that we built in. And then so we've also defined the rendering hints that we actually worked with OpenUSD on. They have been very, very helpful with discussing through this. And so right now we've got shape of the Gaussian, projection used, and sorting method used. I think neither of our groups at this point are settled on what all of those rendering hints are going to be. So if you have other rendering hints that for your specific render you see as a necessary thing, we want to know that because we want to actually evaluate those to see if they're actually something that we need to add in for the wider ecosystem, or if it's maybe a more nuclear case, we can actually assist you in understanding how you could encode that in other methods. And so, I do want to just show this slide. If you've been to a couple other glTF and Gaussian Splatting presentations, you've probably seen this. This kind of shows how this baseline extension that I've just been talking about provides a foundation. We want this extension to be extensible. So today we also have an SPZ extension for compression because ultimately you're going to need to compress the splat somehow. That's actually in production use by both Esri and Cesium and Niantic Spatial as well, but I don't know that they're using the extension necessarily. So that's built on Niantic's SPZ library. We've been contributing back to that too with improvements to SPZ, as has Esri. So, and then if you wanted to, if there's some other additional specification later for compression, we'll be able to do that. And the idea is to just right now provide a basis for building on top of later, and that goes for both OpenUSD's ecosystem and the glTF ecosystem. And so today, both of these are very interoperable and compatible. This table kind of shows it, and yeah, the colors are showing up on the screen, so that's good. There's a few format-specific things with OpenUSD that we didn't copy. OpenUSD does actually support a fallback. Today, actually, if you take that the proposal as is and you pull down the PR and everything, you can actually render the positions of the splats in Storm. You can't actually render the splats in Storm yet, but you can at least render the positions, and so that width scale factor is actually used to dictate how big the point is. And then the color space for spherical harmonics is currently only OpenUSD. On the glTF side, we're still trying to figure out how we want to handle that by default. As many of you probably already know, glTF is sRGB, so we've got things that we need to think through to figure out how we want to handle that. So yeah, we really want your feedback. This QR code will take you to a page that you can go to either of the specifications. Ultimately, we want these to be interoperable, excluding any implementation-specific fields like that width field. And we want to be able to kind of have that round trip and ensure that we've got that round trip. So that's one of the reasons why we're doing this is from the get-go, we saw that we don't want to actually make the interoperability situation worse within the USD and glTF. And so that's why we're working so closely together. So, cool, thank you.
All right. At this point, you've heard from our amazing speakers, and we're going to open up the floor for questions, open discussion. If you have those pain points, we'd love to hear about those use cases. We want to hear from you, because that's really where we thrive, and we covet your feedback and your input. So, does anybody have any questions, comments? None. We did such an amazing job. Okay.
Got one right here.
Oh, sorry.
It's actually for Nick. So, yeah, after you do what are the results from those evaluations? implement the gap evaluations, how do those results actually manifest to the software? Like, does that become plugins for USD, or the schema that you need to import, or where does that become eventually?
Well, all of those, but fundamentally what we want to produce in this group is a set of guidelines. So we'll be publishing a white paper on the MSF website that says here's what we learned, here's what we discovered, here's what we recommend, and links to other resources. There's some suggestion in all of your slides that have reference tooling and libraries and things like that, but I think the most important thing is to describe what to do rather than to actually solve the problems.
Thank you. All right, we've got another question over here.
Well, good afternoon, everybody. Thank you for all of you undertaking this great, important task. And the question I want to ask of all of you, please, is what is the current thinking around enabling USD and glTF to interop with any of the existing AI technologies that are existing out there, in the sense of not necessarily creating 3D, pre-3D images or diffusion images and so on and so forth, but in using both of glTF and USD to help these AIs reason about the world. Structured 3D still has a play in how we do digital twins and training robotics. What is your thinking around enabling glTF and USD to interact with AI? Thank you.
I knew Neil was going to point at me. So, to your point, NVIDIA does have something called USD code. I can't remember. That may not be the name anymore, but basically it creates, it can create Python snippets of USD. So we have the generative piece. I can't speak to any product decisions going forward. I will say that there's a huge focus on NVIDIA now, and Neil can confirm this, around agentic AI and reasoning. So I can imagine that at some point down the road there would be something around that where you would take an existing set of USD nodes and be able to reason sort of about the state of that composition. So from the glTF side, I don't know who wants to answer that.
I think this is a domain where USD is leading the charge, and the Omniverse platform, NVIDIA is just an example of that. It is a main focus for a lot of folks now using. I just come back from China, and all the AI folks, and they're really into using the virtual environments to train agentic devices how to interact spatially. It's a real focus. I think you're going to see it spread out all over the place. It's interesting. It's not just that, though. I mean, it's like you were saying right at the beginning, AI and the metaverse, or 3D and virtual worlds, whatever you want to call it, it is really intersecting in so many different ways. Everything from neural textures and neural materials to generative content, from objects all the way up to foundational model worlds and user interaction. It's AI and 3D are becoming inextractable from each other in so many ways. But this is an important one.
There's a little bit of work, well, a lot of work that really needs to be done, because glTF carries the information and USD carries a lot of the semantic data. We don't necessarily, in fact, NVIDIA provided a schema meant for this, like the USD semantics schema, but there's not strictly enough to use them foundationally for AI as they stand. There needs to be another layer, and I'm not sure who's working that. You're raising your hand as if maybe you're working on it.
No.
I'm hopeful. Somebody's
I wanted to offer that in the late June, early July timeframe, I did publish some work that I've been doing specifically around using model context protocols and exposing parts of USD through that, and also using the Google agent-to-agent protocol as well to do something. And there is a lot of work, in my opinion, required in terms of being able to form the ontology and the conveyance of the semantic information. Otherwise, at least the test that I ran with Claude and Llama, it 1 or 2 steps and it just completely goes off the rails. So you definitely need that semantic information to constrain it to actually get something done. So
Yeah, I've got some MCP prototypes that work on that as well.
So I will say there, please plug, come, if you can, come join AOUSD even to help start up an interest group around that, because I can't imagine that that's not going to be a topic. I don't know if we're on track to do an AI working group or even interest group right now, but something around that would be fantastic to come have those discussions, because it's really the purpose of interest groups in AOUSD is all of those pre-standardization things that really need to be addressed.
Hi, I have a question about the vertex attribute work that you discussed. So I'm curious, there's an example of Primrose as the texture coordinates, right? And oftentimes in USD, they may be defined as face-varying attributes, so like per face vertex, right? And in glTF, they need to be defined as a vertex attribute. So does the work include also sort of this incompatibility between the attribute types, or is it restricted just to like vertex attributes for now? And are there any plans to sort of generalize this to other attribute types?
It explicitly goes into that and says that if you have got like a triangle soup representation, then you're going to have to blast the USD data apart to construct a triangle soup. If you have interleave data, you might have to de-interleave it. There's a whole section on interpreting open subdiv and what it means to turn that into triangles and where the lossedness is and where the inability to express concepts is and so on.
Thank you.
Next question, right here.
This is a question to Nick. So, if we are saving the data in vertices, wouldn't that make the file size heavy?
Not necessarily. Indexing, tables, compression all help out a lot. If all your normals point up, that's one normal in the final file. And I say that with respect to, for example, if it was zip compression. But naively, yes, it can be explosion.
A follow-up to the last 2 questions, is there also potentially recommendations on what extensions glTF could implement to then cover that gap, like in this case of only being, converting something to triangle soup, like, for example, like, it really reinforces the needs for pods to finally be something that glTF supports.
There could be more recommendations, but one recommendation that's already in the document is that glTF relax the strict enumeration from 0 on any of the numbered schemes like colors and texture coordinates, because it's interoperability within the glTF ecosystem problem already. So yes, and there could be more. Please go in and poke stuff in if you like.
Anyone else? Any other questions? Any pain points anyone's dealing with right now? Nobody has any pain points. Wow, we're doing our job. All right, well, I thank you all so much for joining us. And again, we ask you to continue to provide us feedback. Come join us on the Metaverse Standards Forum. Like I said, we cover your input and your use cases. There's also a ton of stickers up here that I'm supposed to plug from Kronos, Metaverse Standards Forum, glTF, etc. So please come grab a sticker. And thank you all to our amazing speakers today. And one last thank you is to Lisi, who has done